Good morning, dear children. In our previous class, we had discussed the physical properties of metals and non-metals. Physical properties like malleability, ductility, sonority, conductivity towards heat and electricity, etc. Today, we are going to learn the chemical properties of metals and non-metals. Chemical properties means chemical reactions. So let us start. Today we are going to learn chemical properties of metals and non-metals. First one, chemical properties of metals. Here we will discuss the reaction of metals with oxygen, water, acids and bases. First, reaction of metals with oxygen. When metals react with oxygen, they form basic metal oxides. You know that during rusting, iron reacts with oxygen in the air to form iron oxide. This iron oxide formed is called rust. Similarly, when magnesium ribbon is burned in the presence of oxygen, it forms a white color ash called magnesium oxide. If the ash obtained on burning of magnesium ribbon is dissolved in water and tested with red and blue litmus paper, we will find that the red litmus paper turns blue. This is because magnesium oxide formed is basic in nature. So we can conclude that metals react with oxygen to form basic metal oxides. Second, reaction of metals with water. Metals react with water to form basic oxides with evolution of heat. Metal oxides are soluble in water and form metal hydroxide. This can be understood clearly by performing an activity. Take a beaker, fill half of it with water. Now carefully cut a small piece of sodium metal. Dry it using a filter paper and wrap it in a small piece of cotton. Put the sodium metal into the beaker. Observe carefully. You will observe that sodium reacts vigorously with water. When reaction stops, touch the beaker. What do you feel? You will feel that the beaker has become hot. This is because the reaction is exothermic and hence heat is evolved. Now test the solution with red and blue litmus paper. The solution turns red litmus paper blue because when sodium reacts with water, it forms sodium hydroxide. Sodium hydroxide is basic in nature. So the red litmus paper turns blue. Thus we can say that metals like sodium reacts vigorously with water to form metal oxides with evolution of heat. Now you will be able to answer why sodium is kept in kerosene. Sodium metal is very reactive. It reacts vigorously with oxygen and water. This reaction is exothermic and hence a lot of heat is evolved. But sodium does not react with kerosene. It is therefore stored in kerosene. Third, reaction of metals with acids. When metals react with acids, hydrogen gas is formed. Let us see an activity to prove this. Take a test tube and a beaker. Pour 5 ml of dilute sulfuric acid into the test tube and 20 ml of soap solution in the beaker. Now drop small pieces of zinc granules into the test tube. What do you observe? You will see bubbles in the test tube. Now allow the bubbles to pass through the soap solution kept in the beaker. Bring a burning matchstick near the mouth of the beaker. Now listen carefully. You will hear a pop sound. What does the pop sound indicate? The pop sound indicates the presence of hydrogen gas. Here, zinc metal react with dilute sulfuric acid to form zinc sulfate and hydrogen gas. Thus, we can say that metals react with acids to produce hydrogen gas. Fourth, reaction of metals with bases. When metals react with bases, hydrogen gas is formed. This can be proved by performing an activity. Prepare a fresh solution of sodium hydroxide by dissolving 3 to 5 pellets of it in 5 ml of water. Drop a piece of aluminum foil into it. Bring a burning matchstick near the mouth of the test tube. Now listen carefully. You will hear a pop sound. What does the pop sound indicate? The pop sound indicates the presence of hydrogen gas. Here, aluminum metal reacts with sodium hydroxide base to form sodium aluminate and hydrogen gas. Thus, we can say that metals react with bases to produce hydrogen gas. Chemical properties of non-metals. Take some sulfur powder in a watch glass. Burn the sulfur powder using a burner. Collect the fumes which are obtained by the burning sulfur in a test tube. Add a few drops of water in the test tube. Now, shake the test tube well. Take both blue and red litmus papers. Dip them in the resultant solution. Observe the changes in the color of both the litmus papers. We can observe that blue litmus paper changes to red. It shows that non-metallic oxides are acidic in nature. Reaction of nonmetals with water. Nonmetals generally do not react with water. Rather, some nonmetals which react with air vigorously are stored in water. Example, phosphorus. Reaction of nonmetals with dilute acid. Generally, nonmetals do not react with dilute acid. Reaction of nonmetals with bases are complex in nature.